Hello, welcome. I'm Bill Wake. We're here today working on the Elm interpreter. We've been at it for a while, and we're up to the point of trying to work on infix operators. We did some work on prefix operators like parenthesis plus parenthesis that acts like a function, and now I want to move on to the regular arithmetic and other operators. So there's different approaches to handling the parsing and analysis of operators, and the Elm syntax is a little funny. There's a couple dimensions where it's funny for us. One is that because like function calls have no parentheses, you have a little more. It's not quite ambiguity, but you can't find out till kind of later in the parse that you've actually got one of these things going and what to do about it. So if you see f of xy, it's just fxy. Oh, that was the test they passed. So it's like, well, where's the operator fit in there? If you see f x y plus 2, does the plus go with the y or does it go with the f of xy? And it turns out it actually goes with f of xy. So it's a little unintuitive. I guess you could probably argue either case, and they had to pick, and they picked. The other thing about it is Elm. Well, they used to have fully user-defined operators. You could make up your own operator, tell whether it was, I think, even prefix or infix, and left or right precedence. And that's gone. But the system operators, the predefined ones, they are defined that way. And there are, I believe there were 10 levels. It might have been 9, but a lot of levels. So parentheses to the highest, and then you had arithmetic plus and minus and multiply and the booleans and all the operators. So the ways to handle that, one way is you make a grammar that has a level for every level of the operator, and then you have some work to do about whether it's right or left associative. That seems painful to me. The other way is you do some upfront analysis, and you build some tables or something to represent the way all that goes, and you sort of end up with more of a 1 or 2 level grammar, and let the table decide when does it do the right thing. I'm leaning towards the latter. I don't think it's terribly. Well, I don't know. See what you think. So the approach I'm thinking of is operator precedence. And basically, it's got this notion, it's got a less than, a greater than, or equal that tells you whether the precedence of something is higher or lower. Okay. And yeah, so that first rule, the precedence, if the precedence is higher, op1 versus op2, then you have op1 greater than op2 and op2 less than op1. But you can have situations where something is greater on one way and not greater on the other, or something like that. So it's a little weird. Okay. Now, if the precedence is equal, then you have an like x plus y plus z. You got to decide, is it x plus y and then add z, or is it x plus y plus z? All right. And I think the only operator that's right associative is the exponent operator. So if you have 2 to the 3 to the 4, that's really take 3 to the 4, which is 27, and then take 2 to the 27th, which is a big number. And, it's not 2 to the 3, which is 9 squared to the 4th. 9 to the 4th is not the same as, 2 to something else, because it's just not. 2 to the 3 is 8. 8 to the 4th. Okay, so you just have to worry about it, I guess. And if you have that situation, then depending on whether it's left associative or right associative, if it's left associative, sort of the default case, the normal case, I guess you'd say, op1 is greater than op2 and op2 is greater than op1. All right. So if you have 5 plus 4 minus 3, you got both of them greater than each other. And then if it's right associative, you have the opposite. Op1 is less than op2. Op2 is less than op1. Okay, for equal precedence operators. And then finally, let's see, op is less than id, and id is less than op. So any identifier is id. So, 4, well, and numbers count too, but if you had 4 plus 3, 4 is less than 3, and 3 is greater than 4. Okay, and then op is less than parenthesis, and left parenthesis is less than op, and right parenthesis is greater than op is greater than right parenthesis. Okay, and then the last one there, op is greater than dollar. That says what happens at the end. Okay, and dollar is just sort of a end of file token or end of string token that we often find handy to have. Okay, and dollar greater than op. All right, and then you have some extra rules, of course. We got parentheses, left equals right. That's the only equals I know of. Left is less than left, and so on. You know, just these are the other rules. All right, now if you apply those rules, I should have put a picture of the table, but basically you're going to build a big table that says operator 1, operator 2, is it less than, equal, or greater than? I mean, it's this little circled less than. Okay, and then we have an algorithm that knows how to work with it. So in the algorithm, you have a stack and you have an input stream. So initially you put end of file on the stack. We'll have some special token, but whatever. And then the input stream W is the input stream. Okay. And so this algorithm, you basically start at the front of the string, and then you check, if dollar is the top of the stack and dollar is the current string, then you're done. Otherwise, you're going to take A and B, the top symbols, the top symbol in the stack, which is an operator. Sorry, it's a terminal, and it's probably an operator or a value. We'd have to see what gets pushed, I guess. But you have the top of the stack and the front of the string, and you compare those. They're either less than, equal, or greater than. So if they're less or equal, you do what they call a shift. You push B on the stack, okay, and move on to the next input. If it's greater, then you do what you call a reduce, which is kind of consolidating, and you're going to pop the stack until you get somebody who's a less than, okay, and so it can kind of consolidate multiple levels, I guess, too. If it's neither less than nor greater than nor equal, I guess you have an error. I'm not sure. There must be there's sort of an implicit blank, I guess, that's an error. Now, I don't know. Basically, I think our strategy is going to be, we'll take those rules on the previous slide and build a table. And the table is the relationship table, the A less than B or A equal B or A greater B or error. Build that table and then feed it in with this algorithm. So what I'm anticipating doing is our grammar is going to, it'll identify function calls and operators and arguments, or it could be variables, could be numbers, whatever, values, I guess. All right, and right now we just put those in a big array. We don't really handle the operators, so it doesn't matter. It's really just f of x, y at this point, function calls, or values. So build the table, use the table with this algorithm on our expression that's really just a list of expressions. And I think, that's going to be our W, our input stream, and it's going to look like function call plus value times value. It'll just be an array of those coming in, and then we'll use our table and just and parse it with that, and the result will be we're going to have some sort of tree structure that represents that. We'll see. The other alternative is we go through and rewrite our grammar to have 9 or 10 levels, and I don't know. It just doesn't appeal to me. Maybe it should. All right. Let's see. So just a quick mic check. It looks good on my end. Is anybody having an issue? Okay. Hey, Code Wrangler. All right. So let's go to our code. And I think, let's see. So our story is infix operators. We got all tests passing. I think everything was checked in. Maybe not the to-do. Yeah, to-do's a little off. Okay. So we're going to do infix operators. I think we're going to take a side tour and try and build up that precedence table. Good, thanks. Build up the precedence table, and it's like that's kind of like a whole separate thing. It's something we would do in advance. We'll somehow find the definitions in the Elm system files. They had like infix L plus 3, and that says plus is an infix operator, left associative precedence number 3. Okay. And we'll let something like that be our inputs as well. Okay, so what we're going to do is, we got to build a precedence table, and that's just going to be kind of like pure coding, one little isolated class. All right, table, and then we're going to, I guess we're going to implement the precedence. It's called operator precedence parser, to work on the array of expressions that we already have. Okay, and then we're gonna have to plug it all in and tie it together. Merge new parser with original parser. So in effect, we're taking a two-level strategy with our parsing. We've got recursive descent for the bulk of the parsing, and it's going to go far enough to identify our expressions, but then it's just putting them in an array of expressions, and we're going to feed that array of expressions to our new parser, and use that for the operator precedence, and then you'll go back to the regular recursive descent. It's been done this way before. It's not an unusual thing. The ding on precedence, operator precedence, is depending on the grammar and the operators and stuff like that, you can get situations where I think what you get is you can have a bad string that gets accepted. Because it doesn't have enough information to know that something went wrong. So I don't know if you had a plus minus, or how about a plus times b, no value in the middle. It might get confused by that, but we're going to avoid that because we've already parsed it with the recursive descent. We know it's grammatically legal, so we're only feeding in good strings. But that's the real ding on them. The other reason they kind of fell out of favor, lots of people went to the parser generators, the Yak and all its descendants, that use the LR kind of parsing. And the operator precedence was kind of, it kind of fed into the notion of LR. I mean, LR is kind of the generalization of operator precedence to always be perfect about syntax errors and to cover everything and all that stuff. So, I don't know, like back in the 60s, maybe, I don't know. I don't know much in the 50s, but certainly in the 60s and into the 70s, there were just tons of parsing methods out there, and lots of compilers. There were different ones, some very ad hoc. We talked about that Fortran one where you just sort of like put in parentheses and around the operator according to their precedence. I mean, just all kinds of stuff going on, and then it settled down to mostly recursive descent. Then the Yak and the LR stuff, a variant of LR came out, and then there are some LL1 parsers. I forget the names, but they're like Yak, but you feed in LL1 grammars. Okay, let's see. So precedence table, implement the parser, merge it in. I think that should do it. Okay, let's see. Just because Code Wrangler had to leave 10 minutes early yesterday, let's just run this and demonstrate that we did get things plugged in. Let's see. So if we apply plus to 321, we should get 24. And if we do times to 7, 8, should be 56. Okay, so it was just pretty straightforward plugging it in, so that was good. All right. So precedence table. I guess we're going to let's start a whole new area. It's different enough. Let's see. So we'll call this operator precedence, and I'm gonna pull it down here. All right. And let's go open that. Well, oops, we'll add a file. All right, this is a test case. Oh, still with this. Okay. Let's see. How about table builder tests? Okay. And this should fail just to make sure we have things hooked up. All right, and I'm going to add the package up here. Rate or precedence. Okay. And we'll move it down. Okay. So, what we're going to do is, the idea is we're going to feed in something that tells, for each operator, we need the operator, we need its precedence level, and we need to know whether it's right or left associative. Okay, so I guess I could genericize that operator. All right, and where is that coming? I guess, I don't know. I'd be willing to pass in. Do I want to mess with tokens? I think token would be the easiest to work with. This can be a number. This can be, I don't know. Can we make a Boolean out of it? Or maybe a little helper type. Yeah. I think a little helper type. Okay, so we want to get in an array of these things. And I think we'll just do a triple for now. You get an array of these things, and then you spit out a table that's the count by the count, okay? And it's the table maps. Well, how do I think of it? Yeah, I guess we want to say, well, it's kind of like operator, and it yields an argument, a relationship. Okay, so you'll give it two operators, the one on the stack and the one on the input stream, and it'll tell you is it less, greater, equal, or error. All right. And let's see. So I guess we want a very simple test. So let's start with just an empty list. Empty list. All right. And what I expect is if you give, let's see, this is the table builder. Is it Precedence table builder? Maybe that's a better name. Builder equal precedence table builder of empty array. And then we want a table out. I guess we'll make it let table equal builder.make. And then I guess we want to assert that something about 0. Well, I guess I'll make that the second expression. We want table dot, what do you call that? Rank or something? it's a square table, so I'll go with size. No, I'm gonna have to look up my math terms. No, dimension, that would be more like 2, I guess. Well, let's go to Wikipedia. I'll spend a little moment on this. Unless dimensions. Yeah, let's run with that. Um, maybe, yeah. It's not the number of dimensions, but it's the size of the dimension. We'll work on the name later. Okay, so you take a table. All right, let's see. So we've got a table builder. We could decide we wanted to add things incrementally. I don't think it matters, but if you imagine we still had the user defined operators and you were parsing them as you go, it might make sense to let the builder just be the thing that handles those statements. But for now, we'll just hard code the beginning. We make the thing into a table, and then we query the table. Can you do anything? All right, that seems like a good start. And we don't have a precedence table builder. Our test is named wrong. Let's name this precedence table builder tests. All right, and then in here we'll put a new class. Switch file. This will be precedence table builder. And it's table builder. Defines class precedence table builder. And we said there was a constructor which takes an array. Basically, it takes an operator, which for us is a token, I think. It takes a level, which is an integer, and it takes an associativity. And I will just call it assoc. All right, and then we'll need to define what an assoc is. All right, but I think an assoc is just an enum. Let's see. Let me get token up here too. All right, so we got minus, plus, and so on. Okay, and we'll just say enum. Whoops. Oh, come on. Enum assoc, and its values are left and right. Is that not contain stored properties? Oh, case. And class precedence builder. Expected identifier after comma in enum. Oh, no commas. Too much time in C and other languages with enums. All right, that takes care of that. Let's go back to our tests. I want to rename this file. Well, let's get something going first. Okay, make. And that thing yields a, well, it's a table. How do we do these? Well, I think we call it a precedence table. Okay, and I'm going to define that here for now. And we'll just make one. Okay. And I think we got one more assertion in there, dimensions. I think for now we'll just let dimensions equals 1. Yeah, -1. Just trying to force a failure. Okay, let's try again. Okay, we can certainly get 0. Yeah, no, in a way, sometimes doing this initial test that's just so trivial, it seems like, you just said return -1, you change it to 0, and wow, not very useful. But the thing it does is it pushes us to get all that mechanism in place, even though we're not doing any actual work. So now let's do some work. Okay, so I got to go back to my rules here. Let's see, can I other way? So if you feed in any operators, well, we start with some default rules. Yeah, so I definitely should have, if I put in left paren, right paren, I should have equals. Now, I don't know, in Swift, I don't know, do I get two-dimensional arrays? Can I write a subscript like that? Yeah, okay. Nested brackets. And that's only by numbers. Yeah, I think this thing is going to be, well, that's what we got to learn. Okay. Let's just try. Well, I think empty list 0 is not correct, actually. Because you have these other operators that you always define. All right, this list down here. Whoops. Yeah, we'll set that aside for a moment. Just trying to get something. So let's do left paren equals right paren. Okay, so if well, we'll grow it. Has initial values, and we're saying it should have an initial value 1 for now, and these are non-operator values. Okay, so let's take, well, I guess dimensions 2, left and right parenthesis, and we're going to assert table sub left parenthesis sub right parenthesis, and we expect that to be relationship. How about operator relation dot less? Is that correct? Should be equal. Okay, left parent equals right parent. Now I don't know. Does right parent equal left parent? They don't tell you. I guess that's an error. Okay, this should be operator relation dot equal, and this is another enum. We'll put them on here, and we may pull these out into separate files at some point. But so our case is less, equal, greater, and error. All right. Okay. Let's see. That should make that. And I'm assuming this dimensions is sort of like a hash table-y kind of thing. I feed in table, I ask it subscript, I get back a something and ask it for a subscript. I don't know. Maybe I'd be better off with how about token relation? Let's just give it the two things, and we know it's a table inside, but that's not really significant. Okay, and then that doesn't exist. Oh, that's okay. We need a relation method that takes two tokens on our table. And it takes token 1 of token 2 of token, and it returns operator relation. Okay, and we'll just return error by default. You're not going to do that for me? I never know when it lets you just, I could say dot error maybe. Yeah, that's the deal. Since it knows it's an operator relation, it can implicitly do that. That helps. All right, and test. So we're saying it should have at least two operators. That's going to fail because we still have 0. And one it should handle left and right parenthesis. Okay, and what are you talking about? Okay, good. Let's see, dimensions. Let me rename it. Oh, I'll get it green first. Keep forgetting. Dimensions. Well, let's do the init first, because I think that's what's really going on. Okay, so init. I'm saying there should be something, and I think that something is it's a variable. It's let's just call it table, and table is a hash table that goes from a token to another token to a relation. Okay. I think I can do that. All right. So that's our two dimensions. We're always asking token 1, then token 2. I don't think we're ever asking for a column or anything like that. Okay. And we want to have table sub token.left parent maps to right parent maps to dot less bracket. Okay, left parent, right parent, expected comma separator. Table, subtoken, equals this, that. Is that the way to do it? Okay, and so I'm saying left parent to right parent is a less. Is that correct? No, it keeps, that's equals. Left parent to a right parent is an equals. Okay, let's. Excuse me. And so accessing this thing, we're going to return table sub token 1, sub token 2. All right. Oh no, it's optional. Otherwise, error. And I think that's actually legit. Oh. Must be unwrapped. Okay. We'll have to deal with ones that aren't there, I guess. But back to our test. I think this should pass. Oh, we didn't do dimensions. Other than that, it should pass. Okay. And dimensions, do we care about it? I don't know that we do. Right? I think all we care is that you give it 2 tokens and it gives you an answer. Or is it less, equal, greater, or error? Okay, let's take that out. I don't think you ever need to know how many things are in the table. It's not really relevant. All right, now I expect to pass. Okay. Now I would love to make this. Oh, I would love to make this read better. Let's do that rename first. This is precedence table builder tests. Okay. All right, we'll commit. Okay. Can I drop token? That would be nice. Can I drop this? I think that would be okay. Yeah. Because all this, that stuff's noise. I really care. Does left parent, right parent equal? Okay. Let's add the next. Left parent is less than less parent. And let me just add a note. We need a test for left first token not found, not in table, yields error. And of course, when I want to test second token not in table, yields error. Okay. All right. And so we had less than less. Make sure I'm consistent. Yes, that is correct. Okay. Should fail. And what does it come back? Probably error. Yep. Good. All right. Let's take a break. Just a couple minutes. Oh, I have to stop at 11:15, so 2.25 hours today. So just for heads up. But 2-minute break right now, and come back and get these other default ones in. Welcome back. All right. So we got less left. Left is less. And we're going to do the same kind of thing. Oh. Ha. Okay, left parent is, let's do it like this. Left parent, right parent is equal. Left parent is less. Okay. I don't know if I can fit that on the same line, maybe. Nope. Okay. I guess it's better off this way. Well, maybe that's okay. No, let's line them up so you can just read them. Yeah. Left parent. No, you can just do that. Okay, it's a bad path to try and get things lined up just so, but that's okay. All right, so I'm saying that should pass. All right, let's go ahead and what's something that's never going to be acceptable? And this is ID. It's really any value, integers, floats, arrays. Although I don't think there's array operators. Well, maybe colon kind of is. Something that never would be here is well, let's look at our tokens. Lexer. Double equals? I don't know. A lot of these things kind of can. Well, we would never expect a new line. Okay, so in this case, and I'm gonna extract out some helpers in a minute here. Okay, so if I had dot new line related to right parenthesis, I'd certainly expect an error, not a blow up. And here, if I had left parenthesis versus new line, I would expect an error. All right, and I think both those will pass. We can. I'm not sure that we have one question mark. Right, because here, if you do table sub token 1, I guess I'm falling in this error case. Let's just change it to equal just to make sure. Now both these should fail. Yeah, and they got equal. Okay. Yeah, I mean, when things kind of pass automatically, I tend to do this to just make sure. Okay. I'm worried I'm on a bad. I'm worried I'm messing up by tokens. Oh, should I be doing this? Well, we'll get it going and then see what happens. I'm a little worried we got expressions coming in there, so it's like function call, and maybe we can do something about that too. But we'll get the table going right, and then if we have to do some adjusting, we'll do that. Okay. All right. That's those. Let's go ahead and fill in the other default ones, and I'm happy to do them as a block. We'll just take this for reference. Okay, so we did the first two. Let's do parend less than id. Now, yeah, when I talk about pulling stuff out, um, I I want to make this simpler to read. So let's just do this. We'll pull the make up here. Do this to be table. And then, I don't know, these assertions, I'm just going to do the same thing here. I mean, what I could get to is like check table, comma, new line, right parend, comma, error. I think this is probably okay. But I could make a custom assertion here, but maybe this should be compare. But anyway, let's add these in. Left parenthesis to id. Do I have duplicate? No. And we'll just do a bunch. Okay, so left parend dot identifier is less dollar. What's that one going to be? Do we have? Well, we have end of file. Let's do that. We can adjust our parser when we get there. Dollar is end of file compared to left parenthesis should be less. That's correct. Identifier compared to end of file should be greater. End of file compared to identifier should be less. Identifier compared to right parend should be greater. And right parend compared to end of file should be greater. And right parend compared to right parend should be greater. Okay. Most of these should fail. Oh, token has no ID. I thought you suggested it to me. Is it name? Wait a minute. Where? Lowercase name, uppercase name. What? This is token. There is a lowercase name. We'll see if that really goes. Huh. Well, oh dear. Do I have to give it a name? X. Okay. I don't know how we're going to manage that. Okay. Error. Now this, let's see, what are we doing? I guess I want these same things over here. Okay, we got the first two. We want parenthesis less than identifier. Left parenthesis, so token dot lowercase name of anything. Can I do that? Is less. No. Okay. Can I do that? Well, it's not going to pass because I'm passing an X and it's matching on empty. Right, yeah, so that one still fails. Okay, so we're going to have to do a little remapping. Let's say I don't know if I'm allowed to reuse this. Okay, so I'm saying we're going to remap tokens so to get to a generic form so we can look them up in our table. I don't think I know a better way to do this. Okay, let's see if we can get one more test passing. 18 should pass now, I hope. I'm using empty string because we'll never get that as a real case, so it's probably okay. And if we do, it maps to itself, so it's still okay. Oh no. Error is not equal to less. Okay. Now let's double check our test. Left parenthesis lowercase name should be less. Left parenthesis says lowercase name should be less. All right. Let's can we break here? I'm going to comment out some stuff and uncomment 18. And whoops. Whoa. Oh, I don't have my test runner here. That's really weird. Something's all right. Has initial non-operator values. Okay, so token 1 is left paren. Token 2 is lowercase name. All right. Now let's look at token 1. Left paren. Token 2. Oh, we didn't genericize token 2. Okay. Try that again. Really, wake up. At least it's running it, even if it doesn't put the dots on there. Okay, and we'll just continue. Okay. Whoops. Now we'll go back to some failing ones, but that's okay. Still isn't waking up. I don't know why I can't just run one test. That's really weird. Okay, end of file to left parenthesis is less. End of file is less than left parenthesis. Identifier is greater than end of file. Name is id is greater than end of file. End of file is less than id. Id is greater than right parenthesis. Right parenthesis. And then right parend. All right. Okay, so we're initialized. Small victory. All right, I think we'll just take this out. And I don't know, I think visually this, well, it's not going to squeak it in. No, maybe I'll just let it be. I'll let the formatter deal with it. Okay. Right. So that's all the stuff you get from an empty one. Now we gotta, I guess the other one is an uppercase name. We should put those in too. I mean, they act the same as lowercase names. So let's, whoops. Let's do uppercase Y. And it doesn't really matter what I put in there because it is going to get mapped away. Okay. These should fail. Okay, so there's lower, upper, lower, upper, lower, upper, lower, upper. Okay, I have the right number of them. And we'll do the same thing here. Lowercase, first case, left parent versus lowercase, uppercase. Left parent, lowercase name. Is less, and so is uppercase name. And here, same deal. And then we need to add kind of a clone of this. Table dot uppercase name. Okay, and I'm hoping that passes. Then we'll do some reorganization. What did we miss? Left paren to uppercase is less. Left paren to uppercase name should be less. Oh, we don't map them right. Okay. Upper. All right. And then I want to kind of sort these by first token. Okay. Left parens, right paren, lowercase name, uppercase name. Okay. And what about in here? Well, these have to organize by their things, so that's okay. Okay, everything should be green. Okay, make precedence table know all default relationships. Good. Okay, now we're going to start passing stuff in. We've only all this so far has been handling the empty case. Let's let's see, what would be the cases here? I guess this is the greater one. So if you give me a list of operators, well, maybe I should do this one first. You give me a list of operators. I should, if they're equal precedence, I should be able to answer this left or right associative. Okay. Or here's this other rule. Ops are always less than identifiers and vice versa. Ops are less than less parentheses. That's kind of a starting point. Right. So if I tell you one operator, let's get rule 3 enforced first. Operator versus default cases. Added operator has default has relation to default cases. Okay. And so we're going to make another table. Whoops. This time, let's just do, we give it plus precedence 5 and dot left associative. We said operator precedence left associative. Okay, and now we want to assert plus versus. I guess we'll take these as a comment here. Such weird formatting. Okay. For any operator, operator is less than identifier. Lower is dot less. And then identifier is greater than dot plus. Yeah, the only thing that check would do, like what if I had if I had check table that this greater than that. I think that would be an improvement on reading it. All right, let's do it. Function check. It takes a table of precedence table. Isn't that a precedence table? Table, it takes a token I don't know what I did. We have precedence table there. Is it because it's not public? That seems weird. It's not very picky about that. Precedence token 1 is a token. Token 2 is a token. And relation is a precedence operator relation. Okay. Oops. And his job is something like this. Token 1, token 2, and relation. Let's pause this a minute. Let's backfill these. Okay, so this is left paren. Equal right paren. Left paren equal right paren. Left paren equal right paren. I'll comment it. Left lowercase. Left paren. Right paren. Oh, I'm messing this thing up. Left paren, right paren, left paren, left paren. One dot. left paren less. See if my hypothesis is right. Is this easier or not? Now the lowercase name is less. Left paren is less than lowercase name, yes. Left paren is less than uppercase name.